Hi everyone and welcome to this video. In the previous video we have spent a lot of time and with the stacks and a stack with arrays also. So we have done kind of you have good understanding of what actually stack is, and you have implemented also a stack using array. Okay, and in this video I'll be taking on I will be talking about how efficient our code that we have coded in our previous video means stack using array is. So take out the time complexity of our stack using array and we'll do some modification, and the modification that I will do here it is. So in our previous video we have coded a kind of a small thing like a push. We have coded a push and we have written an exception. If our array is full, then we have to return that this is full, we can't add anything. But it has to be more flexible. So what in this video I will simply I will not give error to the person who has filled up. Means let's say you have this array, this a stack with the array, and you have kind of a full, means 4 3 2 1 hasn't full by the user, but you want more flexible, so we will increase this by a double, means again 4, and if again reaches again 4, if again reaches again 4, so we'll make more flexible. We'll double the capacity of our stack with arrays. Okay, so first let's do the modification and then we'll come back and then we'll understand actually and then we will take out the time complexity of all those things. Okay, so here we have written the code in our previous video. Is that here it is. So first of all we have made two variables for being on the same page. Let me get you familiar with these all. So first of all I make an array of data which will store the element into that. We ought to store the top, and we have saved -1 because of we don't know in index of the top. Okay, then we have made this constructor, and if the user does not provide any kind of argument, the length or the capacity of our stack or the array would be 10. If the user gives the capacity, then our array of length will be that. Okay, now here is a function for checking out is our array or stack, a stack of array is empty, or we will take the size, and we are doing +1 is because let's say you want to take out, let's say your size is 0, you have only one you don't have any kind of let's say element into the stack. So what will happen, you have -1 +1 means 0. Okay, so you don't have any kind of it will return 0 because your stack is empty. Then we have taken a top, and top has some exception over here that we had. If the top means the same as -1, then we'll say that then we'll throw the error that your stack is empty. And I've not written the code anything in stack empty. Watch that previous video what I've done. Okay, and then we are returning data as the index top. If it is not empty, then we will return the top. And then I have written push, but in that push I have written this. I have set it the full exception, but now I will modify this by doubling the capacity. I will call the function by double capacity. I've written that, but I will write it again. So double capacity, and that will double the capacity if the size if the size fulfilled, means we have full array, then you'll double those, means again kind of the capacity will be there. Okay, so I have made a private, and it should be private because I don't want this function to be used by any of them other user. Okay, so well, first of all what you have to do, first of all let's make a plan for this. Well, what we are going to do is, let's say you have an array like this. We have a stack of array like this, 1 2 3 and 4, and it's full, and it is full. So we can simply make an array which is double of this size, means 1 2 3 4 1 2 3 4, means total 8. We have a space of 8, so we can fill 1 2 3 4. We can map this out using for loop, and again if you want to put 5, you can put over here, and if it again it's over, then we'll make another array which will like this. Okay, so like that will do. So first of all let's store this into the temp. Let's store this kind of elements into the temp, and then we will for mapping it out, and then we'll increase the size of a data, and then we'll map using for a loop. Okay, so let's start. First of all, I will make a int temp equals to the kind of data, all the elements. Okay, then what I will do, I will increase my data. I will increase the size of our data int, and this will be 2 times the length of our previous data, means previous kind of array of stack. Okay, so have I get a data dot length. This is how we can write. And now we have a 8. Let's say your kind of you have full with 4. You have a previously 4. So now your shape will be 8. Now we'll map this 4, and 4 will be preserved. So what you can do, you can write a for loop for int. I think all you are able to see this if I'm not wrong. Yeah. Okay. Int r equals 0. I smaller than r equals to top. R equals to top because we have a top, so it should be all the elements, and I plus plus. And if you want to do dry run to understand what a top is actually doing, you can do that to get better understanding actually what a top is doing if you're getting confused. Okay, so and now what we can map it. We can map ith element from 0th element, first element, second element. We can map ith element onto the we can map the ith element of the data. We can map the ith element of the data which we have stored in temp into the data, into the new data that we have made. Okay, so this is the new one that we have made with a double capacity, and this is the previous one that we have stored over here, Okay, so now you are done. Now it should work fine. Save this and you're good to go. Okay, pretty much is what I'm trying to say here. Okay, just you can check this function out there, then you can understand it much better. Okay, so let's take out a time complexity in a fast way. So first of all, let's take out. So first of what in this we are not doing with any of the size. Means we are just taking we are just checking it. We are just checking is empty. We're just checking it. So we are not anything dealing with the size, or we are not looping over. We are just dealing with means we are just return. We are just checking if it is -1 or not. Okay, so it looks like this is order of 1. It has a complexity of order of 1 because it does not have a lot of complexity over here. It is just order of 1 because it's just a checks. And size also just adds up, so it is also order of 1. Okay, top, what is doing, it is just giving it a top index. It is this is order of 1. This is order of 1. Okay, push is let it be doing like this. Let me show you what it's doing. It is doing double capacity. So you can see, let's go over here, that we are looping over n times of an array. Okay, so it seems to have n times of an array, so it seems to have an order of n. Okay, the time complexity of this loop is order of n. So let's write it out that the complexity is order of n. So you may think, hey, the push will be the order of n also, and this is just the order of 1. This is just order of 1 because it's just putting the element on the top of the data by plussing up the data. Okay, just pushing it up. So it is not doing any kind of size. We're not dealing with the size, so it is just order of n till here. But sometimes it is also doing order of n if our capacity of our array is large. If full. Okay, so in an average we can take this as also order of 1. It happens sometime. It happens, double capacity happens sometime if your kind of data or your the size of an array is full. Okay, so it happens sometime. So in an average we can take this order of 1. Okay, there is no way to deal with this rather than writing a for a loop. Either you can do that. We'll see later. I don't know. I even don't know how to map the kind of I have not dealt with it till now. Okay, so on an average, I'm writing it up average as an order of n. So it seems like that, and until now we have order of n, and its pop is just, it is not dealing with any other size. It is just decreasing the data. It is just kind of what I can say. decreasing the size, or it's just removing the top element, nothing much. Okay, not going through size, it's not looping over, it is just removing or decreasing the size, and it automatically removes the first element. So it is also order of 1. Order of 1. And it seems like that all the functions are very efficient, okay. So it seems like that our code is very good, and we perform very best, and on an average you can take this whole code is order of 1, okay, and it performed very well and quickly. Okay, so I think that you got better familiar with one modification and also the time complexity of our array. Stack of arrays. Okay, in the next video we had done with stack with arrays. In the next video we'll talk about a stack with linked list. And if you want to try it out, you can try with these functions will be also be integrated over there. Just try it out and take a look at that if you can do or not. But if you're not, don't be demotivated. It's just simple. Even I was not doing at that point, but it's very simple. In the next video we will be doing we will be talking about it will be more minutes of video. We'll be implementing a stack using linked list. Okay, so I hope that you have already watched my linked list video before going on to the next video, because it will confuse you if you don't know about linked list. Okay, so thank you for seeing this video. I'll be catching up in the next video. Till then, bye bye.